Hi students, and welcome to Preliminary Chemistry, the Chemical Earth video series, and this particular video which is looking at different types of molecules. Now we want to keep building on our understanding of the different types of compounds that are there. So remember that firstly, compounds are pure substances that consist of two or more elements in a fixed ratio. And compounds form through the attraction of ions or through the sharing of electrons. So if electrons are gained or lost, then we have ions and they can form compounds. And also if electrons are shared between atoms, they too can form compounds. So the first category are ionic compounds, and these are formed by the donation and acceptance of an electron. So in this situation, the potassium has one electron in its outer shell. The bromine has 7 electrons in its outer shell. We just used the Lewis structure to show this. And so therefore, when this compound is formed, the electron from the potassium is going to be donated to the bromine. Potassium will lose its electron. Bromine will gain an electron. And as a result, the potassium ends up with an overall positive charge. The bromine has a overall negative charge, and these opposites attract. Now, the thing with ionic compounds is they tend to form networks because each individual cation attracts anions in all directions. Covalent compounds, on the other hand, form when electrons are shared. For carbon, carbon has 4 valence electrons in its outer shell, so it actually ideally likes to form 4 different bonds. Oxygen, on the other hand, has 6 electrons in its outer shell. The best way for these two to combine is for the oxygen to have its 6 and actually create a double bond. So that, actually I'll just redraw that because I'm showing single bonds there. So the oxygen is actually going to have only 4 of its electrons not involved, and those two are going to be linking with a carbon. That carbon is also going to link with another oxygen, which is also going to have its electrons distributed like this. Now what this means is that we actually have 2 electrons here and 2 electrons here, 2 electrons here and 2 electrons here. So this is a double bond. So the structure of carbon dioxide is actually oxygen double bonded to carbon, double bonded to oxygen, and then we've got a couple of unbonded electrons around the 2 oxygen atoms. This is a discrete molecule. There are no networks here because one molecule of carbon dioxide is just 1 carbon and 2 oxygens, and they don't attract carbons and oxygens in all directions. So that brings us to this whole idea of the difference between networks or arrays and molecular substances. So an ionic substance forms a network of ions. So if you think of our potassium, which has a positive charge, it's attracted to the bromine, which has a negative charge, in basically all dimensions. Up, down, left, right, and into and out of the page. This forms a great network because, of course, this bromine is also attracted to another potassium, and so is this one, and so is this one, and another bromine, and so on. And so we could draw these forever. This is just an on-growing network of ions, all attracted to one another, and I've still only shown them in 2 dimensions and not in 3. Covalent substances can actually do both of these things. Diamond is one of the hardest substances we know of because diamond is just carbons bonded to each other in a network arrangement. Now, it's not a sort of box structure like the way I've drawn it because it's a 3-dimensional structure, and in fact, each of the carbons is linked in a particular shape called a tetrahedron, and we'll see that when we use the model kits again. So it's a three-dimensional structure that's hard to show in 2 dimensions, but effectively every carbon is bonded to 4 other carbons in a network structure. But something like water is a discrete molecule. 1 oxygen, 2 hydrogens, that's a water molecule. Okay, it can be held to other water molecules, but there is no continuous bonding in the way that we see for both diamond and for the ionic substances. So that brings us, I guess, to the different ways in which we can find a number of different types of molecules. Because elements can also exist in molecular forms. So just as we had carbon dioxide or water existing as discrete molecules, but each of these were compounds because they are made up of more than one element, elements can also exist as molecules. Oxygen is referred to as a diatomic molecule because this particular molecule has 2 atoms of oxygen. Contrast that with ozone, which is triatomic. It actually has 3 atoms of oxygen. Now, interestingly enough, the noble gases, of which helium is one, actually exist as what we call monatomic elements. And hopefully you remember that mono means 1. So this is actually an atom, which is also a discrete molecule. It will not form ionic or covalent substances because its outer shells are already filled, and so it is stable as a single atom, or what we refer to for just the noble gases as a monatomic molecule. Thanks for watching.